Pete Yost here. Jake and Steve and I just want to thank Huber Engineered Woods for their sponsorship of our Unbuild It podcast. It's easy to speak well of a company when they use building science and systems thinking to develop working systems for high-performance buildings. That certainly goes for the ZIP system. The ZIP system integrates all four control layers: water, air, vapor, and thermal. Its components, polymer bonded coating on OSB, acrylic PSA tape, stretched sill-pan flashing, and liquid flash sealant are all top-of-the-line building products, compatible and designed for durability. Throw in the ZIP R panels for continuous exterior insulation, and that's all four control layers. Seem a bit too good to be true? Then consider their system 30-year warranty, their complete online set of info resources, and their top-notch tech hotline. Be the best with the best.
Hey guys, real quick before we start the podcast, Jake Bruton here. While we have fairly decent podcasting equipment, we totally don't understand how to use all the software yet. So about 10, 11 minutes into this podcast, there's a extremely weird 10 seconds or 15 seconds of the podcast. Give us a break. We promise we'll get that kind of thing sorted out. When I say us, I really mean me, because it was my fault.
Welcome back to the Unbuild It podcast. This is Pete Yost, and I'm here with my building buddies, Steve Basic and Jake Bruton.
Hello, everybody.
And our topic for today's podcast is control layers. And I asked to start off this conversation because I actually remember, and Steve can back me up on this, that it was at a Building Science Corporation summer camp where Eric Burnett, a professor of building science and technology at Penn State University, stood up and said, we have to stop calling these things barriers. We need to call them control layers because all we can do is manage heat and moisture flows. We can't really stop it. So it's in that context that we'd like to talk about the four control layers. And I'm going to throw it over to Steve just because this is pivotal to his work as an architect to sort of start the conversation.
Well, I think it's, control layers, back up 1 second and simply ask that simple question of why do we build, right? Well, we build something because we don't want to live out there. We want to live in here. So what are we trying to do? What are we trying to say by moving from out there to in here? We want to gain control, right? So it always baffles me that we talk about creating this environment that we control, but then when I have conversations with builders, architects, etc., they talk about things like, oh, you want the house to breathe, you want this, you want that. But why do I want to forfeit control, right? The whole purpose of if I can build an airtight, watertight structure, like say a submarine, then I get to control everything that happens inside it. And the more control I gain, probably it's likely that the less amount of energy I have to provide to manipulate that environment because I've gained control.
And just to back up another step is what control layers are we talking about? And in work for building science where we're looking at managing both moisture flows and heat flows, our order of priority is number one, the water control layer, number two, air, number three, vapor, and number four, heat. And Jake, I want to turn over to you because you have an interesting way of talking about that with your site guys.
So whenever I talk to my guys on site and I say water, air, vapor, thermal, there's a little bit of like, I don't know what you're talking about in it. And while those terms make perfect sense to somebody that's paid attention to control layers before and the ideas behind them, I choose to say those four things slightly different when I'm talking to my on-site guys. I say first, liquid water, and they understand that means things like groundwater and rain. And then I say air movement, because we're not trying to make the house so that it doesn't have air in it. We're trying to get the house to not be sharing air. And then I say water vapor, because when I just say vapor to some of my on-site guys, I always get the head nod. And then I always say heat. And the discussion is, well, what about cool? Well, cool movement is the same thing as heat transfer. It's just we're talking about which direction are we talking about the heat is going to move. So it's, for me, it's liquid water, air movement, water vapor, and heat transfer.
And I think that, one important aspect to state that we hear all the time when we're out there talking and speaking, Peter, is, well, do I really have to worry about it? I'm down here in Houston, or do I really have to have, that much insulation or triple glazed window, or whatever the case is? But keep in mind, you're creating control, but what we're controlling is the environment. So my answer is always, well, do you purchase energy to manipulate that environment? Are you trying to manipulate an environment? And if the answers are yes, then it really doesn't matter whether you're in Miami, Houston, or International Falls, Minnesota. You're buying energy to manipulate the environment. So control layers are important, but also the components that we use and break down in our assemblies to use to battle that control and gain that control is very important pretty much everywhere.
And when we're talking about control layers, the focus is on continuity, right? That the real way to have embody control is that they're continuous. And I was just working with an architecture firm yesterday where they said, well, we really like you to do a review of our plan set and specs on this project. What's your perspective? And I said, okay, I'm going to evaluate the control layers and their continuity. And it was, I think, a brand new concept for just about everybody on their team. But during the conversation and the review, you could see them making the shift. Like, all right, this is a new, I love the way you do this, Steve. You as an architect simply say, if you're going to give me a new constraint, fine. I just need to prioritize that in my drawings as a new constraint.
Right. And one of the analogies that I love to use that's pertinent here is think of our bodies as a system, right? We gain control. Our body has dedicated inputs, outputs. The air that we breathe not only comes in a dedicated input, but it goes directly to a filter, that is our lungs, and then gets transferred into our bloodstream, etc. But not unlike our houses, our bodies have certain control layers, right? Our skin controls the amount of moisture. It holds all our cells and body together, but you don't pour a cup of water on your hand and it just kind of flows into your body, right? There's some level of control there for liquid water and water management. And our houses, think of them the same way.
And I would say that continuity conversation that Pete's talking about, again, for job sites, I always talk about, okay, open the door. If you just crack the door, you did the same thing as leaving those seams untaped. You let an opening be in whatever air barrier, whatever water barrier, whatever we're talking about. I always tell my guys, think about, this is the same as leaving the door cracked. This continuity disappears when we open a window or we crack a door. Those things are the same as making sure that things are continuous, because you have an easy explanation of how something's not continuous when you open that door.
And if we're talking prioritizing these layers, and we do it in the order of water management being the most important, I think a real stumbling block for a lot of people, it certainly was for me, really? Thermal's at the end of the list? You're telling me the insulation is sort of the least important?
Yeah.
And, that's a tough pill to swallow if, throughout your building career, the code has been all about the energy.
Yeah, and I mean, I know you've heard me talk about it, Peter, when I talk about control layers, but I say, thermal, there obviously is some building science to keeping condensing surfaces warm, and we're going to get into that. But thermal, for me, is a financial equation. How much insulation can I afford to put at this house, right? Water management is a totally different. You can't sit there and say, well, I really can't afford all those flashings, so I'm just going to put half of them in. Well, that's not getting the continuity, where the only real problem with thermal, if you cut it by 20%, is your energy bills probably will go up if you solve for the other three, which is why thermal is at the end. Because if I solve for those, then thermal pretty much just becomes a financial equation.
So what you're saying is by cutting back on thermal management, we might get a ding on our energy bill, but the house isn't going to fall down. But cutting back on water management, we have more concerns with longevity of our assemblies to start out with.
Yeah, so let me throw out one of my more favorite sayings. If it don't last, it don't matter, right? If you could build the most energy efficient, build R80 walls, R100 walls, whatever you want to throw at it, hang I-joists off the side of the building, but if it doesn't last, it doesn't matter. And what I'm going to turn this, I'm going to throw it right back at you, Jake, because I love your story of when you started out in building, what the exercise that you went through personally to understand what kills building. So back at you. I won't take it away from you.
So after I felt like I had a grasp of how to run a construction company, I started looking at what's the next frontier. How am I going to be a better builder? And I was having a really hard time. I was reading magazines and books, and I really was having a hard time deciding what the next year or two of my life was going to be focused on from a business. Starting again. Ask me the question one more time, Steve. Sorry.
So I'm going to throw that back at you, Jake, and you got a really good story on how you came to understand water management.
So when I had been in business for a few years, and I owned the business, and I felt like that I had figured out how to operate a construction business,
I was trying to figure out what the next phase of my construction process was going to be, what the thing was that I was going to be focusing on to make myself a better builder. And I started Googling construction litigation. I started looking for why are people getting sued. And I realized that people were getting sued because of water. Almost exclusively water. Yeah, there's the random lawsuit where somebody mismanaged funds and they couldn't afford to finish building the building. But it's almost always water. And that's scary.
Yeah, and what does that equate to, right? In the previous episode there where I talked about the cliches of the whys, who's, what's, when, where, to information, getting back to that why, well, why is that so scary? Because it involves two things. It involves that word risk, right? Water puts us at risk. We're at battle with Mother Nature. And two, risk usually translates to dollars or litigation or problems or repairs or whatever the case is. But it comes back to that. And I commend you, because when you told me the story, I was like, man, that's a no-brainer. But I wonder how many builders really sat back and said, what's my number one problem as a builder? What will I be confronted with? And what a great answer.
So, Steve, I'm going to throw you a softball. What's the primary tool that you use on a set of plans to evaluate control layer continuity?
Well, there's, for when you're talking about air, there's obviously the red line test, but let's say generically, we'll just say the line test, right? I should be able to take any detail and profile it. You and I both have talked extensively about that, about being able to profile a detail. And it's not only about architects, right? It's when I was in architecture school, believe it or not, one of my professors talked to, when he applied to Columbia University, he was able to use architecture as a second language in his application for his PhD there. And because it truly is, if you truly understand it, right? I mean, it's a illustrative or graphic language, but nonetheless, it's a language, right? Because not only does it get written and devised in details and drawn up, but it gets interpreted by the builders. So you have to rely on multiple parties understanding the same language. It's a graphic language.
But then the line test, or sometimes it's called the pen test, is take your finger, your cursor, or your pencil and trace from the footing all the way up to the ridge without lifting off the page. And I love the way that you picked certain areas. Like, you're going to have a jump here. I guarantee you're going to have to do a creative leap to get past this. And also, it's about compatibility of materials. So when we talk about control layers, it's not just continuity. It's, well, what are the materials you're using? You know, for example, in the water management layer, I can't tell you the number of times as a builder that I just connected to whatever was convenient, right? So, for example, the window cap above a window. Oh, if I'm doing vinyl siding, that J channel looks a little bit like a piece of flashing. I'm just going to treat it like a piece of flashing. You know, really creative thinking, and it was a jump. It was a leap that the building couldn't make. And so, you know, I learned later from Joe that continuity of the water management layer is connecting your weather-resistant barrier to flashings at penetrations. Oh, okay. I always have to do that? You mean I can't caulk around a window to create, you know, the barrier? No, you can't. You have to connect the concealed drainage plane to the flashings rather than jumping back and forth to whatever's convenient for you.
And I'm going to take that one step further, because I think we're making the deeper dive here into just talking about the water management control layer, and we'll save the other three for another conversation. But in talking about water management, I totally agree. There's two efforts that happen in my mind when I think about water management. There is, how do I shed water and get rid of it, right? There's the two famous words that Joe said, down and out. Use gravity in your favor with water, and then get it the hell away from you as fast as you possibly can, so there isn't a problem, right? He would always say, oh, well, all windows leak. Well, they only leak if they see water, right? You can't have a leak if you don't have water. So get rid of the water. But the second part of my point is, not only are we trying to shed water, but we have to be informed in understanding that when we're keeping water out, we have to have drying potential, right? We have to have the ability to dry should it get wet. That's why it's called water management, and not like the Penn State guy said, barrier, right?
Water barrier.
Because it isn't a water barrier, because a water barrier would suggest a dam or something like that. But it's water management, because the second part of the backside of the coin for me is, what happens if water gets in? How do I dry that system out? How do I manage water when my system fails? Because if you're planning a building for 100 years, 200 years, or whatever, chances are there's going to be some level of failure, some little leak somewhere that you have to plan for, right?
So let's get down and dirty, super specific. Let's talk about, say, an assembly that you and I have built together, Steve. Let's start with a roof, and let's talk about what that does for the building. And we can start with what you were just saying. How does something dry? So we're going to push as many times as possible to have a vented assembly, correct? In our roof, we're going to have vents in the soffit and a ridge vent to make air move through that assembly and dry the possibility of a leak in a shingle assembly on a roof.
Yeah, I think the first level of any system is deterrence, right? How do I not allow the problem to exist, first of all? So, I mean, the first thing that comes to mind is, a fisherman's hat. I got this, the Gloucester fisherman in my mind, but what does his hat have? It has a big wide brim on it. Why does it have a big wide brim? To keep the water off of his face so he can do his job when he's out there getting splashed with waves and water, right? So the same with our houses. What's the first level of defense in water management for our homes? Put a big hat on it, right? And if you're not going to do that, then you certainly have to up your water management game. But, the little side note I'll tell you is, and this is coming from the building investigation side at Building Science and working with Peter and such, is that, Mother Nature's a formidable opponent, right? She might sacrifice a battle or two, but she will win the war. So you have to play according to her rules. You can't go in there like some bully and start throwing Mother Nature around, because you will lose.
Yeah, So there is the the issue of face sealed assemblies as opposed to water managed. And just as a general rule of thumb, if you're at 20 inches of precipitation or less, yeah, you might be able to design assemblies where you're face sealing at the plane of the cladding to keep or to manage water. But most of the United States is in areas where there's more than 20 inches of precipitation, and now we're doing a management system behind that the weather resistant barrier.
And Peter, just to put that in perspective for our listeners, when we talk about 20 inches, we're talking about like a Las Vegas scenario. We're talking about, New Mexico, those kinds of areas. We're certainly not talking about Houston. We're not talking about New Orleans. We're not talking about Boston. Right. So, just to put it in perspective for our listeners there.
Okay, so Steve, we have these large overhangs that is our fisherman's hat on top of our house, and we have a vented assembly, and then it goes straight back to the comment that you made about if our system will be challenged or not. So now we've limited the amount of water that can actually, or bulk water that is actually going to get on our walls, but it doesn't mean that we just give up and don't worry about it. When we transfer to our walls, what does a wall assembly look like that's water managed?
Right. And I think, again, that first line of defense is design, right? Because there's also the thing that sticks in the back of my head is years and years ago when we were doing work with, I think it was Town and Country Homes out in just outside of Chicago, and they were talking about one of their number one callbacks, and it was literally sliding glass doors and two-story walls, and that they had major problems. And that was a very expensive callback. And it wasn't necessarily like, okay, we had to fix the leak, but think about that for a second. Wall leaks, the sliding glass door is probably attached to like a dining room or a nook or some kind of space that has a hardwood floor. So they would explain it like, the minute we get that leak, we got to pull the door. Chances are we either got to pull up flooring or we got to knock it down and sand it, which means then we have to refinish all the floors on the first floor so we get the same color. So they were running into these huge expenses because of that one simple leak. So in a lot of my designs, one of the things, not only do I like big overhangs, but when I have areas of large glass like sliding glass doors, etc., I like to put them under the canopy of a back patio or something that not only puts a visor over them, but it's an extended visor. So I can say, holy crap, I'm scared to death of this door going in this wall. How can I protect it?
And so we're actually dealing with that. My firm, Arrow Building, is dealing with that right now. I got a callback on a house that's probably 2.5 years old. It's south-facing wall that is 12 feet tall, and the original design from the architect had an awning over this door, this particular just swinging steel insulated door. And due to budget reasons, the awning was postponed. It's not cut, but it's been postponed, and that awning hasn't happened yet. And I actually got a call back. That door is leaking. It's very minor, and I actually think that it's a slab to threshold connection that's actually leaking. I don't think it's our installation. I think it's the manufacturer's product. But had that awning been installed, that door wouldn't even see water, and we wouldn't have an issue.
Yeah, so this issue of exposure comes up too. I remember when Steve and I were going over the details for Green Building Advisor with Mike Girton, and Steve had drawn the typical sort of 3x5 baby tins that go up along the side of a chimney to flash it. And Mike Girton says, those aren't flashing. Flashings need to be 10 by 16. And we're looking at him like, what are you, crazy? Nobody uses 10 by 16. Well, where's Mike Girton from? He's from coastal Providence, right? So he needs 10 by 16 flashing around his chimney because of the exposure level he gets. So, if you're building a one-story bungalow with 2-foot overhangs in a grotto, you can probably get away with just that deflecting 2-foot overhang. But if you're doing it on coastal New England or a 50-mile stretch of building on the northern end of Lake Champlain in Vermont, you're going to have to build more like a boat than a bungalow.
Yeah, and Peter, what comes to mind for me is I tell builders it's funny because I do a lot of coastal work, Scituate, Cohasset, up and down the New England coast, but it's like you do a house inland versus one on the ocean, literally facing the water, right? The thing I tell the builder is we got to get these details right, because guess what? Somebody that can afford that property, they can afford a lot of lawyers, and they probably want a lot of glass. So what does that mean? It means your risk is elevated exponentially because of the location, the exposure, but also the financial effort of that client, right? They can go to endless means to bury you if you don't get it right out there, as opposed to building that house, 100 miles inland in central Massachusetts or something in an apple orchard. It's a totally different product. So that when you look at these projects, and if you're a builder working with an architect, that first thing is, how do I get rid of water? That's the first level of water management. How do I get rid of it? And when I say get rid of it, not meaning get it and get rid of it, but how do I just not make it part of the problem, and then deal with the water that I can't get rid of that becomes part of my problem.
And so the conversation a lot of times, if we're continuing this work down from the roof, we're on the wall now, and we're talking about windows and doors, the callback to last week's episode about information, I would make a really strong argument that you have to make some decisions when you look at the manufacturer's recommendations, and you have to really judge what they're telling you is great and perfect and is going to work for them, because I don't know how many window manufacturers I disagree with their installation methods when it comes to connecting even the simplest of water control layers.
Yeah, and I know Peter's, he's revving up, because this is where Peter and I are, our worlds part. It's extremely rare, but I know Peter's gonna, and I'm gonna let him talk about it, but I'm gonna kind of start it off with the challenge for any manufacturer is they want to sell their product, and they're honestly not in charge of the assemblies, whether you believe it or not. Window manufacturers sell windows. In my eyes, that means the window shouldn't leak. Well, someone else should be in charge of how that window goes into the opening. And we're going to get into a fun discussion here. I know we are, because we have in the past. But it is a challenge. There's so many pieces to that water management of simply putting a window into an opening in the wall. And I'll let Peter, give us his opinion here.
What is Pete's take on this? Let's get into the weeds here.
Well, what you can't see is the smoke coming out of my ears while Steve is talking. Yeah, no, I think this is a great conversation, because I think that product manufacturers have a responsibility to understand the performance of their individual products, but also understand and contribute to the way that they fit together. And I have a real strong preference for companies that take responsibility for the sort of the system integration of the products they sell. I'm not saying that Steve doesn't think this, but I think Steve as an architect says, hey, that's my job. My job is to make sure that I understand how these things fit together, and to provide with the construction documents, the drawings, and the specs, how we actually achieve that. But I think that product manufacturers have a responsibility to at least work with building professionals to make sure that stuff fits together. And we have examples of companies like Huber Engineered Woods that says, look, we've got the zip wall system, but we have the OSB, the polymeric coating, the zip tape, the Silpan flashing, stretch tape, and Prosoco liquid flash, because they want to provide a suite of water management products that fit into total water management. So,
and they are,
I'm not.
And they're viewing, we're using Huber as a good example, and they're viewing this both as an opportunity to cut my risk down, but they're also using it as an opportunity for themselves to be able to sell us more stuff. And that's a win-win,
exactly.
Right?
Right. But my point of view, that where I see it slightly different, is as the architect, I see myself as the maestro, right, of the orchestra. And my opinion is that, the person playing the violin shouldn't, I mean, they have a little bit of association with the person playing the trumpet, certainly, but they're concerned about the violin section and when they play. And then they listen, and it's okay, somebody else's job when the trumpets or trombone or whatever is going on. As the maestro, it's my job to make sure that their interaction is professionally connected, right? And so when we talk about it, yeah, Huber does an exceptional job, and in some ways I think they go beyond what they're really required to provide. But Huber can take us to, okay, here's our product, we're a sheathing, but if you take our sheathing and you cut a hole in it, here's how to prepare that hole for a window. And then as the industry professional, it's my job to take the window from the manufacturer that says, hey, here's a window, it doesn't leak, it needs to go in the hole. Well, the responsibility of taking that product and putting it in that hole, that's my job. I'm the maestro. I knit it together.
Yeah, I can't believe I'm going to do this, but I'm going to applaud you, Steve, for the fact that I've seen you go out to job sites and take a set of details that you've drawn and then see how the crew actually puts them together. And not all architects do that, right? They don't really want necessarily to see how that gets translated from the detail and the specs into the actual installation. But I've talked to a number of builders, and I've told them, look, if you're going to switch to a different way of installing windows and doors at penetrations, you're almost certainly going to have to do a mock-up or work with the architect on the installation of the first window or door to make sure that the will of the manufacturer, and I can't believe I'm going to call you a maestro, because that's an image of you standing on a little podium in front of a group of people with a little tiny baton, and I don't want to go there. But that's what's got to happen.
But yeah, and Peter, one of the things, when I do these projects and I have the window, not only, I'll give you an example. We did this project down in Falmouth, and the day we did it, I had the window manufacturer's rep out there. I had the Huber rep out there. I was out there. The builder was out there with his guys that were going to actually install the window. And we installed a window together, all of us, with the whole team. When the window was done, I looked at all the members, Huber, the gentlemen from the Sierra Pacific, the rep there, and asked them all, are we satisfied with the way this one window was done? When I got a yes across the board, I looked at the builder and said, now go do the other 40, just like we did this one. Because now we're all in agreement. We all have, invested in the game. And when I go out to the field, it's a couple things. People say, well, we talked about where do you get your information? Well, as an architect, what better place to get information on framing a house than to go out there, climb up on a ladder, sit down on a rafter, and have a 5-minute conversation with the framer that's actually been doing it for 25 years and ask him a couple simple questions. Hey, was my layout, did it work? Was there anything that you found that was wrong? And I tell him, I'm a big boy. Tell me if I made a mistake, please let me know. It's not uncommon. It's going to happen. We have a lot to do, but gaining that information as a young architect, if you're a young architect listener or a young builder, have these conversations. Just don't sit there. Ask the dumb questions. Ask the question that is extremely obvious, and that's how you get your knowledge, and that's how you could take that knowledge and turn it into a benefit for yourself.
As a builder, I applaud every one of my subs when they show up with a list of questions that they have. That ability to acknowledge that somebody else might be seeing things differently than you, even if you feel that you're smarter than them, is incredible. I love it. Because I know that when my plumber shows up with a list, it's his list going, I think Jake's wrong about this. It's not him going, I think Jake knows better than I do. I think it's him challenging me, and I like that. And I think that's a really good piece of advice. And to continue the conversation, is it okay if we all agree to not use the word maestro in reference to Steve from here on out in the podcast?
You know what, guys? I mean, you're really painting the daunting picture for our listeners here on when you start a concept or a portion of the podcast by saying, I can't believe I'm agreeing with Steve. That really hurts me,
I
guys.
think it'll be a
I'm a lover,
recurring
not a
theme.
fighter, man, and you guys are
You
stabbing
just
me right
got
in the
done
heart.
saying you're a big boy, and
I
you
know,
can
but
take
I'm a
it.
panda inside. I got to say I'm a big boy because people got to believe that. That's that whole Marine Corps thing talking there. But I'm deep down, I'm a very, very sensitive.
Oh boy.
And Andy has a new word of the day calendar, hence the word maestro today.
There you go.
So now we have windows and doors installed in our assembly, and we have to revert back to the idea of what happens if it gets wet. So if we're talking about cladding installation, we're talking about a rain screen, and we're talking about our water control layer also being that layer, that zip system or that WRB, whatever it is. But then that thing works better because we're adding in other aspects to our assembly.
Yeah, so I mean, I think, we certainly touched on the water management part. And, I tell people the minute you break out a caulk gun, you break out a piece of tape or a piece of flashing, certainly the easy question to answer is, what am I keeping out, right? The hard question to answer is, what am I keeping in should this assembly fail, or should water get on the side of that flashing that I don't want it on? How does it get out? How does that problem? Because no buildings fail, and correct me if I'm wrong here, Peter, but no buildings fail because water management was correct, right? They fail because you sealed water in the building somehow, and it didn't have the ability to get out. Um, but I mean,
Nothing
Yeah,
nothing bothers me more than when I get a phone call from a client about something leaking and they say, "Well, we tried caulking it." And I'm just like, "Ugh. Can you do me a favor and just go out there and cut the caulking out before I even come to see what you did?"
yeah, and I think this boils down to, I mean, just to go back to Steve's comments about design. I was working on a project, or I am working on a project where it's a flush design. So it's an architect decided to build a low slope roof, did use a vented rain screen, but there's absolutely no overhang anywhere on this building. Well, can you do that? Absolutely, you can. But the pressure you place on your water management system is inordinate. It's just not, why go there? But this also brings up the issue of physics and chemistry. We often say, let's do the physics right, because that's sort of the easiest way to manage the moisture. When we move over to chemistry, all right, now we're relying upon complicated big polymers to do our job, and that's going to put more pressure on the building. And that's a big issue with a lot of different systems in terms of whether or not we do the physics right first and then move on to chemistry.
yeah, I mean, that's certainly a great point. I mean, for us to believe that we can sit here for 35, 40 minutes and give you everything you ever need to know about water management is pretty naive, given that cumulatively we probably have about 75 years of experience in dealing with water. But I think there's certainly a lot more to be said on this topic. So
But
We'll
at
be
the same
coming back to it
time,
for sure.
isn't everything that needs to be said about the topic down and out and continuity? Like,
yeah, I mean, I would tell people, if you were looking for a handful of takeaways here, yes, continuity is the key. It always is, right? Because if I think about any one of the control layers and I have a breaking continuity, all I've done is increase the focus of the problem from, instead of being 10 feet across the building, now it's only a foot across the building, but most likely it's probably working harder and heavier in that area. So the problem is exponentially worse. And the whole idea of whenever you're taping flashing, I see that's one of the things that makes me cringe the most on Instagram. Is I see people using ice and water shield very liberally, or any kind of adhered membrane, and saying, oh, I put this on to keep water out. Okay, that's great, but what happens when water gets on the backside of that? It doesn't have the ability to get out anymore. And those are the key features, and the down and out. I mean, and down and out is not just the roof. It is every assembly in the building and every component in the assembly should be working towards down and out and getting rid of water. Just get rid of the problem. I can't state it enough.
In terms of gems to take from this discussion, Linda Brock wrote a book called Designing the Exterior Wall. She's an architecture professor in British Columbia. And the little gem she has I love is every surface that's not vertical is a roof. And if you apply that to your building, there's all these little places where surfaces are not vertical, and you should be thinking of that as a roof. It works really well to go to the areas where you have to change the way you think about water management.
Okay, so I would say my final thoughts from a builder's perspective are hire an architect that is willing to look at things and go, okay, where's the water going to go? And then teach all of your on-site guys and all of your carpenters to go, okay, where's the water going to go? And I think if you combine everything we just said, you have a really good starting point for water management and your water control layer. And I think that because we're at the, somewhere close to 40 minutes, we're going to make this a 2-part podcast. So today was water control layers and the water control layer. Sorry, Steve, go ahead.
No, I was just saying, yeah, let's, I'm with you. We're make this multiple, and I think we could take even a deeper dive into the water management and talk about things like rain screens and window installations, et cetera, et cetera.
So as an introduction to Building Science 101, this is Control Layers Part 1. And next week we'll publish an episode that is Control Layers Part 2, and we will talk about air, vapor, and thermal, or air management, water vapor, and heat movement in that order of importance. And we want to say thank you for checking out the Unbuild It podcast this week. Thanks for sticking with us. Tune in next week, and you can find all three of us on Instagram. It's jake.bruton on Instagram, and I'll let you two introduce your own Instagram accounts.
Mine's pretty easy. Steve Basic Architect.
I have no idea what mine is. Go to my website. That's building-right with a W.com.
Okay, thank you guys.